Hi, welcome to this lesson on trigonometry, trigonometric functions part 2. Let's have a look at question 4. We're given the functions f of x equals cos 2x and g of x equals tan x plus 2 in the interval negative 180 degrees to 90 degrees inclusive. We want to sketch the graphs of f and g and clearly label all intercepts, asymptotes, turning points, and endpoints. Okay, so before we do that, let's just have a look at these two functions. For f of x, we have cos 2x, so the only parameter that's affecting the parent graph cos x is that b value of 2, which basically says that your new period, right, of this graph f is going to be 360 degrees of cos divided by 2, which is 180 degrees. So we expect in a 180 degree interval that we'll have a full cosine wave. G of x is tan of x plus 2. So the only thing that's affecting the parent function tan x is this plus 2 at the end, which is your q value. That means it's the standard tan x graph, but shifted up 2 units. Okay, so I'm going to go ahead and draw the function tan x plus 2 first, and I'm going to do it in blue. So what are the important properties of tan? Well, they are asymptotes. The first one being at x equals 90 degrees. And the period of the asymptotes is the period of the tan graph, which is 180 degrees. So that means there's another asymptote here at negative 90 degrees. And make sure to label those. Okay, so we've labeled all the asymptotes. Okay, and then for tan x plus 2, we can just take some of the special values, right? So we know tan of 0 degrees is 0. Then plus 2 will give you 2. So here's the y-intercept at 0 degrees, 2. At 45 degrees, we know tan of 45 is 1, and 1 plus 2 is 3. So over here, we have 45 degrees and 3. At negative 45 degrees, you're going to have negative 1 for tan. Plus 2 gives you a value of 1. All right, and so on. So we can actually sketch this graph, and it'll look something like this. Okay, there's a full tan wave. Okay, and you can see from negative 90 to 90, that's a full 180 degrees. So there's a full tan wave inside that interval. Okay, and then we can continue. Tan of negative 135 degrees, right? So if we had to do that using special angles, we know tan satisfies the odd identities, the odd trig identity. So we can pull out the negative tan of 135 degrees. And tan of 135 degrees from our cast diagram, that's over here. Only sign is positive in that second quadrant, so it's going to be negative of negative tan 45 degrees, because it's 45 from the horizontal. So it's going to be negative tan 45, which is positive tan 45, which is 1. So at negative 135 degrees, the value is positive 1 here. And tan of 180 degrees, that's a special angle as well, is 0. Right? So we get 0 and then 3. So for tan of 135, it's 1 plus 2. Let's make sure we get that right. Right, for the function g of x, so it gives you at 3 over there. And then tan of 180 is 0, plus 2 is 2. So it'll go like that. Right, so there's the endpoint 180 degrees and 2. All right, and then for the cos 2x graph, we'll draw in red. We know that in a 180 degree interval, it's going to complete one full wave. But let's just take the special value. So at 0 degrees, cos of 2 times 0 degrees is cos of 0, which is 1. So there's the y-intercept, 0 degrees, 1. At 45 degrees, you're going to have cos of 2 times 45, which is cos of 90, which is 0. So there's a x-intercept, 45 degrees, 0. And then at 90, you're going to have 90 times 2 is 180, and cos of 180 is negative 1. So here we're going to have negative 1 here, and that's an endpoint. 90 degrees, negative 1. Okay, and then negative 45 degrees is going to give you cos of negative 90. But cos of negative 90, right, cos is an even function, so it's the same as cos of 90 degrees, and that's 0. Okay, so at negative 45 degrees, it is an x-intercept. At negative 90 degrees, same thing here, we're going to get cos of negative 180, which is the same as cos of 180, and that is negative 1. Okay, and that is a minimum point, minimum turning point. At negative 135, you're going to get cos of negative 270, which is the same as cos of 270 degrees. That's going to give you 0, so that's another intercept. And then at 180 degrees, you're going to get, or negative 180 is going to get cos of negative 360, which is cos of 360, and that's 1. So that's an endpoint there. 360 degrees, 1. So we can now connect this graph as follows. All right, and there is the graph of f. Okay, so here's g, here's f. Another way we could have done this is that if we bring up our table function, we can actually put two functions at once on certain calculators. Otherwise, you'll do it one at a time. But for this one here, we can do cos of 2x and then tan of alpha x plus 2. And we can start at negative 180, end at 90, and do steps of 45 as given in the diagram. And you can see when x is negative 180, f of x, which is our blue graph, gives you a value. What did I put as f of x here? Let's just go back and check. Cos 2x, yes. Okay. Oh, sorry. The blue graph is your g. Okay, so everything was right there. So f of x here, that is your cos 2x, which is your red graph. Negative 180. That should be negative 180. Okay, so let's just fix that over there. Negative 180 degrees. Okay, so negative 180 degrees, it's 1, and then for the g of x, it's 2. So we've got those endpoints right. At negative 135, the red graph is 0, and the blue graph is 3, which we've got right. At negative 90, the red graph is negative 1, so I should put negative 90 there. So let's just fix these points up here, make sure we've got them all right. Okay, negative 90 degrees, then that is negative 1, and then you see it's error for g of x, which makes sense. That is the asymptote. At negative 45 degrees, you can see the red graph goes to 0 and the blue graph goes to 1. At 0 degrees, you can see the red graph goes through 1 and the blue graph goes to 2, and so on. So the calculator gives us all the relevant points as well that we can use to sketch the graph. Okay, and then lastly, using the graphs, determine the approximate values of x in that interval for which cos 2x minus 2 is less than tan x. So we need to somehow manipulate this to make it look like the two functions. Well, there's cos 2x, and we know that's f of x. And we've got tan x here, but if we bring the negative 2 over, we have cos 2x is less than or equal to tan x plus 2. So now we have the inequality f of x less than or equals to g of x. So we're looking for when is the f graph, in our case the red graph, when is it below the blue graph, g of x. So the red graph, can you see from negative 180 degrees, it is strictly below the blue graph, all the way up until the asymptote, essentially, up till negative 90 degrees. So after the asymptote, can you see now the red graph is now above the blue graph. So we do not consider that interval, because we want when the red graph is below the blue graph. But then there's a point of intersection here somewhere, okay? And there's an x value here, and then from that point of intersection all the way to 90 degrees, can you see the red graph is below the blue graph? So essentially it's the entire interval, so from negative 180 degrees up until 90 degrees, union from this point of intersection, if I call it capital A, okay, because we want, is it or equals to, yes, so we can put our close brackets, up until the point 90 degrees. So if we can just work out what that A value is, then we're good. But notice that they say use the graph, determine the approximate values. So why they say that is because you might not be able to solve this equation, this trigonometric equation, using the standard methods that we have developed. And that is actually the case. We can't without some form of numerical analysis. So what we need to do is approximate using the graph. So if we look here, right, this A value, it's partway between negative 90 degrees and negative 45 degrees. It almost looks like it could be 2/3 of the way, but not precisely. So I would say this is almost like 60% of the way between negative 45 and negative 90. Okay, so there are 45 degrees separating those two numbers. So I would say, what is 60% of 45 degrees? So I go on my calculator, and I go 0.6, that's 60% of 45 degrees, and that's about 27 degrees. So I would say from negative 45, if I moved over 27 degrees to the left, So from negative 45 minus another 27 degrees, that gives me about negative 72 degrees. So that is an approximate value. Okay, and then there's a y value where it intersects, but we're only interested in the x value. So that negative 72 degrees, that's an approximation of that point of intersection. Okay, now because we cannot solve this analytically, the two trigonometric equations that we have, the approximation means that you will be given a certain range of values in that are acceptable, right? And this is one of the acceptable values inside that range. The actual acceptable error, according to the observer, the one who created the actual question, gave a leeway between negative 65 and negative 75 degrees. So anywhere between negative 65 and negative 75, if your approximation was close within that range, you will get the solution answered correctly. All right, so that's how we would do these types of questions. I'll see you in the next one.